Number 31, the distance d an accelerating object travels in t seconds can be modeled by this equation here. And a is your acceleration. And let's see, if a car accelerates from 20 meters per second and travels a distance of 80, how many seconds? So this is a substitution problem into your equation. So our distance that was traveled is 80 equals 1/2 a, and that was 20, times our time squared. So let's see, this is going to give me 80 equals 10t squared. So let's see, that's going to give me 8 equals t squared. So let's see, between what numbers? Well, I know 1 squared is 1, 2 squared is 4, 3 squared is 9. So it has to be between somewhere between 2 and 3. So that's answer choice B. Number 32, we are solving an equation or an inequality, and you do treat that just like you would any equal sign. So if we do that, we have x plus 3 is greater than x plus 5. And hopefully you notice when we try to get our x values together, we get the statement 3 is greater than 5. Now, we know 3 is definitely not greater than 5, or most people do. So when this happens, this is a false statement. And if you get a false statement, then you're going to get an empty set. That means you're not going to have any elements in your answer. Now, if you got a true statement, that would be answer choice G. That would be if you got a true statement. Let's say your x is canceled out and you had maybe 5 is greater than 3. Then my answer would have been G, all real numbers. A survey in a study skills class asked 20 students enrolled in the class how many hours, rounded to the nearest hour, they spend studying on the previous evening. The 20 responses are summarized below in the histogram. What fraction of the students responded that they had spent less than 3 hours studying? So I would come up here and see less than 3 hours studying. Well, notice that number of students and number of hours. So here's 2 students here, and this would be 5 and 6, 4, another 2, and then here just 1 student. So that would make it a little easier for us to glance up. And we know we had a total of 20 students that answered. And now let's see, spent less than 3 hours studying. So less than 3 hours studying would be 2 hours, 1 hour, or no hours studying. So what numbers go with that? That would be 6 plus 5 plus 2. So it looks like we're going to get answer choice D. Number 34. The teacher decides to show the data in a circle graph or a pie chart. What should be the measure of the central angle sector for 3 hours? So for that, we need to see, well, how many were 3 hours? And that's going to be 4 out of the 20. So 4 out of the 20, or it reduces to be 1/5. Now, the measure of the central angle sector, well, you just need to see it. You know all the way around the circle is 360 degrees. So really, I need 1/5 of 360. So if I multiply that, that's really going to be 1/5 times 360. And so our central angle here, 360 divided by 5, should be 72 degrees. So this statement really sounded very scary, but you see how it really isn't at the end. 35, to the nearest tenth of an hour, what is the average number of hours for the 20 survey responses? So we're going to have to find an average. So let's count up how many total hours we would have studied. So we had 2 to study 0. So we have 2 times 0 plus, and we had 5 students to study 1 hour, plus we had 6 students to study 2 hours. So here I'm really just going through seeing our total number here. Let's see, we had 6 to study 2 hours, 4 to study 3, 2 to study 4, and 5 to study 1. So let's see, we have 0 plus 5 plus 12 plus 12 plus 8 plus 5. So we have 10 plus 20, so that's 30, plus 12 is 42. So 42 hours. And let's see, we wanted the average number of hours per 20, and they did survey 20. So that's going to give me roughly, let's see, 2.1. So that's going to be answer choice B. Number 36, pentagons have 5 diagonals as illustrated below. So how many diagonals would an octagon have? And to me, this is a time-wasting problem. You can do the formula, and this is what I would do instead of drawing it. Your formula is the number of sides times the number of sides less 3, all divided by 2. And so an octagon has 8 sides, so that's going to be 8 times, well, 8 less 3 is 5, divided by 2, so we see that we get 20 for our number of diagonals. Right, moving on to number 37. The bottom of a basket of a hot air balloon is parallel to the ground, and yada, yada, yada. We skim through the problem, and I would skim down to the actual meat of the question. Which of the following expressions gives the distance in feet from the center of the bottom of the basket to the ground? So this side here, that's what we're looking for. So it looks like we're going to need some trig. And we're looking from our angle of 72 degrees. So this side over here would be opposite, and this side would be adjacent. So that means we need our trig function sine. So to set up this problem, we're going to say sine of 72 degrees. And I would stop there and just start canceling out everything that doesn't have sine of 72. So that's going to give you some help. So sine of 72 equals opposite over hypotenuse. And you see now to solve for that side, we would need to multiply 144 over to the other side. So my answer choice is E. I almost circled the wrong answer choice. Okay, moving. The coordinates of the endpoints of GH in the standard form of the coordinate plane is 8, -8, -3, and 2, 3. What is the coordinate of the midpoint? So the midpoint is the middle of these. So let's just focus on these two values. I want the middle of that distance. Well, we've got -8. And let's see, we went from -8 all the way over to 2. And then I want half of that distance. So that's going to give me -6 over 2. So I should have a midpoint, or the x-coordinate of the midpoint is going to be G, -3. Moving on to 39. Well, this one is kind of a tricky problem. There's 2x plus 3y equals 4, 5x plus 6y equals 7. Well, guess what 8x plus 9y is going to have to be equal to? 10. It's going to be 10. Imagine that. How strange. Now, we could go through and solve this, but it will always work out to be that because it's the way it's going up in order. Okay, number 40. Number 40, what are the values of theta between 0 and 2 pi when tangent of theta equals -1? And this is straight from our unit circle. So let's remind ourselves of what those values would be for tangent. Let's see, when tangent is negative, well, all trig functions are positive here. Only sine, only tangent, only cosine. So if we're going to talk about the first quadrant, now we'll go ahead and draw in the second quadrant. This is going to be pi over 4 in the first quadrant. And this one down here, we're going to say 1 plus 4 is 5 pi over 4. Now these are where tangent would be positive. So automatically we can mark out, let's see, if we want tangent to be negative 1, well, it can't be f, and it can't be g. So notice very quickly, just remembering where tangent was positive, well, that leaves us with our only two answer choices because, again, j would be wrong and k would be wrong. So my correct answer would have to be h. Number 41. Is it possible, a possible value of I to the x? Well, I goes through a series. I to the first is just I. I to the second is negative 1. I to the third is going to be I squared times I to the first, or negative I. And I to the fourth, well, that's really going to be I squared times I squared, which is positive 1. So from that list, which of the ones could be a possible value for I to some power? That's positive 1 is going to be B. All the values of I will be one of those four values. There won't be anything outside of that. Okay, a can of soda pop has the shape of a right circular cylinder. So we have a can here. Excuse my poor pitiful drawing. So this is what we have here, and it gives us the dimensions of this. We are told the inside height is going to be 6. So, and normally you see you've got a radius and then you've got this height here, and that height is 6. And the inside diameter is 2 inches, so I know then that my radius is 1. When you pour the soda can from a full can into a cylindrical glass, so we're going to pour it into a glass. So let's go ahead and grab that shape again. But we're going to have some different measures with this glass. The inside diameter is 3 inches, so that means that here, 3 inches, that's going to be 1.5. If we're going to talk about the radius. So how many inches high will be the soda? So here we're looking for this H on this shape here. So let's plug into our formula and see what we get. So they give us the formula, so that was really nice of them. And so I'm going to use this formula here. So my volume that I have over here in this first shape, I have pi times my radius squared times the height. And so that gives me 6 pi. Now I'm going to take that volume and pour into this measurement over here. So I'm going to say 6 pi because that is the volume that I'm transferring. So 6 pi equals, and let me change colors here. So 6 pi, that's the volume, equals pi, and the radius over here is 1.5 squared times the height, and that's what I want to know. What is that new height? So this is going to be, and the pi's will cancel. 6 equals 2.25 times h, and so when I divide both sides by 2.25, I find that the height is 2.66 repeating. So here the height is 2.66 repeating. So really that's probably going to end up being 2 2/3. So that's going to give us answer choice F. Okay, looking at number 43, again continuing on with this, the height and radius of the right circular cylinder below are given in meters. What is the volume? So again, using the formula that they just gave us, we're going to go through and plug in. And so I know my volume is going to be pi. So we have pi times, and notice we had our radius squared. So our radius squared is going to be 25, and then times our height, which is 6. So that's going to give us 150 pi. So that's answer choice C. Okay, number 44 is a kind of a tricky problem. The key to this is to realize we have these similar triangles. This triangle here is going to be similar to this triangle here. And then that in turn will be similar to this triangle down here. So we do have all those similar triangles going on. Now, something for us to realize from our statement, the ratio of our perimeters, so triangle, if we had triangle ABC, the ratio of that perimeter to AFG is going to be 1 to 3. Now, our goal is to be able to find the ratio of A to C. So I'm trying to find this other ratio. And let me erase here where I've shown the similar triangles. So we're trying to find, well, what is the ratio of AC? What is this ratio to CE? Well, let's think about all these triangles being similar. Well, from this first statement with the perimeter, that means that AC is to ratio to AG. AG is 1 to 3. And something else, since we do have triangle, let's see, triangle ABC is similar to the triangle, let's see, ADE. So with those triangles being similar, and we see that DE is similar to FG, or is a ratio to FG, is going to be a 2 to 3 ratio. Now, so let's think about this. We also have this other triangle we said was ADE, so I'm going to take that triangle, ADE, and that is going to be similar to triangle AFG, the big triangle. So we can say DE is similar to, and so let's look at that ratio there. So DE is similar to FG, and that's what we're told is 2 to 3. So let's see, we've got the ratio 2 to 3. So let's think about these side lengths, because again, I'm trying to prove something about AC to CE. Well, let's go back and keep in mind what we know based on some of these new given things. Well, DE to FG, well, let's see, we know AG, that measure is 3, to, let's say, AE, well, AE, that's going to be 2. But we already know that the measure of AC, that similarity was 1. So it only leaves to reason that here the comparing of AC to CE would have to be 1, which is F. Okay, and number 45. Number 45, it can get tricky as well. Now, notice that we have all these different paths. It's almost like a parametric. And a rocket lifted from a launch pad and traveled vertically at 30 kilometers. And then it traveled 40 kilometers at a 30 degree from the vertical. And then traveled 100 kilometers at a 45 degree from the vertical. So how many kilometers above the height of the launch pad has the rocket traveled? Well, let's see, we're looking for that little question mark. Now we can divide this up into different triangles, and that's what I would do to start off. So I would start at this very top part where it was turned, and I would draw this perpendicular here. And notice that here is the hypotenuse, and this part of the angle is 45, so this part in here would also be 45. Now, if we remember then, if that base angle is 45, and we have a 90 degree, this up here is also 45. And if we remember those special right triangles, then I know this side here is going to be 50 root 2. A little bit of review here. We would have our hypotenuse as x. This would be x root 2 and x root 2. And these base angles would be congruent here. So I know part of that is 50 root 2. And so we need to continue drawing in. And it looks like the next easiest thing to draw in would be this side here. And with that side there, let's see, how could we calculate that one? Well, this just looks like a rectangle. So I know that's going to be 30. So let's go ahead. We've got enough to try to pick out our answer choices. We have 50 root 2, and we have 30. So let's see, what would that have to end up? Let's see, we have 30, and we have 50 root 2, and then we still have this missing part that we're not sure about. So we do know, let's see, gosh, it looks like we're going to have to, we don't even have to finish this. It looks like it's going to be E, because we know we have 30, we have 50 root 2, and then to find this other portion here, that would have to measure to be 20 root 3. All right, number 46, skimming through the question, it looks like this is an expected value problem. These tend to come up. Expected value, well, you have your number, and you have your probability, and you multiply each one, and then you add it up. That's your expected value. So from the product here, I get 0. 1 times 0.2 is 0.2. 2 times 0.05, so that's going to be 0.1. And if I multiply here, that's going to be 0.15. And all we have to do is add these up. So if we add these up, well, if we've lined up our decimals right, we don't even have to finish adding these up, because this is going to be the only one that ends in a 5. So 46 is answer choice G. All right, 47, the height above the ground in h units of an object is being thrown is given blah, 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 blah. An equivalent factored form of this equation shows that, my goodness, so it looks like we're going to have to factor this. Oh no. Well, let's see. And just looking at the answer choices, it might be a maximum height. Starts at 2 units off the ground. Does this really start at 2 units off the ground? Well, oh, it looks like it starts here off the ground. So I don't think that's going to be it, even before I've even started. So it looks like reaches a maximum height or reaches the ground. So let's see. Let's go ahead and factor this. I don't think we've got too much of a choice here. We can factor out a -2 out of every term. So I'm going to have a positive t squared minus 5t minus 8. No, minus 24. Good gosh. I'm on crack today. Sorry, folks. So minus 24. And I was looking at the 8 in the answer choice. That's silly. Let's go ahead and factor this. So that's going to give me, what can I multiply? Gives me 24. Take those same two numbers, subtract them, and get -5. So it's going to be a -8 and a +3. And so let's see. If we're talking about, I think it's going to be answer choice E, reaches the ground. Well, if we're on the ground, the height is 0. And so if I set each part equal to 0, t minus a equals 0, so t would be 8. So that would be the time that the height is 0, which means the object is on the ground. So 47 should be answer choice E. 48. Oh my gracious, what a terrible looking problem. Working this out, and I, of course, will not do as much as I possibly could here. I'm going to think about this as, okay, that means I need a grouping of 2. Now, a quick way to simplify this, well, what is 5 divided by 2? Well, it's 2.5, isn't it? So I have g squared already there, and this is going to be the exponents. So I'm going to have times another g squared, because that means that many can come out. But this 1/2 means I have a g left under the radical. So I would look to see, well, where do I have a g to the 4th at? Because that's going to have to be there. Well, I don't have a g to the 4th in F, and I don't have it in G. I do in H, and I do in J. So dadgum, we're going to have to keep going. So let's simplify here. Well, think about, again, what I said with the little power here and our root. So if I take 5 and I divide it by 4, that's 1 1/4. So that means in addition to the h squared that I had outside, I have another h to pull out. And then I have 1 left under the radical. So let's examine what's out here. So that's going to be h to the 3rd. So let's see, what answer choice would that have to be where I have an h to the 3rd and a g to the 4th? That would be answer choice H. And notice I just completely ignored the stuff under the radical, and that should always work. All right, and number 49. We have logarithms, and with logarithms, let's see, there's all kind of rules that we always tend to forget. One big rule that people tend to forget, that exponent needs to move down to the front. So it's 13/2 times log base 5 of 5. Anytime your base and your number here are the same, that cancels out to 1. So really I have 13/2 times 1, which is 13/2. And so the answer to that, well, that's going to be what? 6.5, isn't it? So where's my answer going to fall? Well, D, between 6 and 7. All right, number 50. And let's just read the question and give us all the stuff. And let's see, this person will sign a contract to rent a size 3 unit for 12 months. And at the current special rate, the amount Daria will pay for 12 months at a current special rate represents the % decrease from the regular. Okay, so let's see what we've got to do here. Well, our special rate, so we have $1. So I have $1 plus, and for the next 11 months, she's going to pay $100. Okay, so that looks like we're going to get 1101. And let's see what, and we want to know, let's see, Daria will pay for 12 months at a current special rate represents what % decrease? Well, what would it normally be? What was it normally? Well, normally it would have been what, say it would have been $1,200 normally. So let's see, let's find that percentage. So I have 1101 over 1200. So that's going to be roughly 91.75%. And so what % decreases that? So we're going to take our 100% and subtract those. And if we do that, we should get 8.25%. So that's going to be answer choice F. Okay, moving on to 51. Size 5 units can be subdivided to form other sizes of units. What is the greatest number of size 1 units that can be formed from a single size 5? So this sounds like a good dividing problem. So let's find the units of size 5. So size 5, that area is an 8 by 16. So 8 by 16, and that's going to give us 128. And let's see, we want to know, well, how many size 1s can fit in there? Well, size 1 is a 2 by 4, so 8. So let's divide these. So 128 divided by 8, that should give us 16. So that's going to be answer choice E. All right, and let's look at number 52. And look at our answer choices. That's kind of crazy. So let's see. The owner of a storage facility is considering building new units that have the same floor dimensions, larger than size 5. She will use the floor area to determine the heating requirements of these larger units. For this calculation, Janelle will use the relationship between the unit size number and the respective floor area for size 1 through 5. Which of the following expressions gives the floor area in square meters of size X storage? Oh me. So let's see. In area 1, it was going to be, or size 1 had a floor dimension that's going to be 8. And let's see, 2 was 16, 3 was 32, and let's see, 4, 64, and 5, let's see, 8 times 16, so 128. All right, so, well, I'll put equals there. So, first thing I would notice about the square, or the area, notice this is going to be, based on our answer choices, that is 2 to the 3rd. This is 2 to the 4th. And this is 2 to the 5th. And so, let's see, as we keep on, 2 to the 6th, 2 to the 7th, 7th. So, looking at that in our area, it looks like here from 1 we got 3, from 2 we got 4, from 3 to 5. So it looks like we're getting 2 raised to the, let's see, gosh, it looks like we're skipping a 2 here or adding 2 to that. So it looks like we have to have an exponent of 2. I don't think it's F or G. These don't even have exponents, so it looks like it's going to be H. And I would agree, this is 2 plus 1. And this one would be the next 2 plus 2, and then 2 plus 3, and 2 plus 4. So the correct answer there should be H. Okay, number 53. Notice it's talking about, and I'm just skimming through the problem, and it says the period of the function, and it goes through a really long, detailed mess here. Skimming through all of that, if you want to know what the period of a function is, it's going to be the horizontal distance needed before we start repeating ourselves. And since we're talking about distance, let's start here. And let's see, if we trace our function, we don't repeat until we come right back up to here. Notice, and then from this, it's the same pattern. So what is the value here at that repeating moment? It is pi. So notice here, my answer choice for this should be B, and the period is pi. All right, moving on to the next problem. And again, very similar. It looks like it would be very intimidating, but hopefully we can make it through it. The first part says 2 times u, so find your vector u, multiply that by 2, and you're going to get 10, 6. Plus negative 3 times vector v. So find vector v and multiply that by negative 3, so I get negative 3 times 2 is negative 6 and positive 21. And I don't have the components for w. That's what I'm looking for. And then equals 0. And now we can add together what we need. So let's see, 10 and negative 6, that's going to give me 4. 6 and 21 is 27. And plus w equals 0. So a couple of ways you can think about it. One, we need the opposite of vector w in order to get a 0. So what's the opposite of 427? That's negative 4 and negative 27. So that is answer choice G. Right, and number 55, this one, instead of being able to plug in some answer choices, which would be ideal if you're just solving for x, but it wants to know how many values of x make this true. And so what we're going to have to do is actually solve this. Now the problem is 9. We need to change 9 to be 3 to some power. And so we have 3 to the x plus 1. That's going to have to be equal to, now 9 is really 3 squared. And I already have x minus 2 as an exponent. So what I would have to do is multiply these. Well, since you have bases that are the same, you essentially think about those bases as canceling each other out if you want to. And so you have x plus 1 equals, and if we do our distributive property, we have minus 4. And so if I subtract my x over, I have an x. And if I add 4 over here, I have 5. So notice we only get one solution. So my answer choice is B. All right, number 56 is a hellacious problem. God help us all on this thing. It looks very intimidating. After you read through it, you will see that you have a triangle and you're given an area formula. So here's the area formula. And what we want to know is the original area. When will the second or other part of the area, when this side BC is decreasing, and it's decreasing and the length is given by that part there, when will that new area be half of the original? So as we go through and set this up, it really just becomes two equations, and as you work through it, it gets a little bit easier, but it just seems to be a god-awful problem. Starting out, we want to know, well, we want half of the original area, so that's 1/2 of 1/2, and I'm just plugging into that given area formula times sine of, and it said our angle is theta. Now that is going to be equal to, and again AC is constant and my angle C is constant, so it's going to be equal to, and we can set up this other formula, 1/2 times 20, so notice they're the same, but this side over here is going to be replaced with the function 15 minus 2t, because that's going to be the length of that side at any given time t, times sine of theta. So now let's start canceling some of what we can, because do realize we are multiplying all of this and we're setting it equal. So this first set of 1/2s are going to cancel. It looks like our 20s will cancel. And our sine thetas will cancel. So even though this problem looked horrendous to start out with, notice from the first part I just have 1/2 times 15. That's all that's left on that side, is equal to 15 times 2 minus, or 15 minus 2t. Let me fix that. I'm on crack again. So we have 15 minus, good gracious. Guys, I have really jacked this problem up. It is just 15 minus 2t, isn't it, folks? Oh, goodness. All right, so we need to solve this. So a couple of ways. I would just deal with the fraction itself. That's 15 over 2. And then so that's equal to 15 minus 2t. Some people would rather multiply everything by 2 if you want to. It would be 30 minus 40. Sometimes that's a little bit easier to deal with. And in your heads, y'all can figure out that equation. Subtract 30 over Divide by -4, and so that's going to give you 15/4. And that's going to give you T. So that's going to be answer choice H. And number 57, every day you get asked about how many distinct permutations can you make of the letters in the word people. That's just a normal everyday thing. The way you do this problem is going to be a fraction. And the first thing is you need to count how many total letters you have. So people has 6 letters, so 6 factorial. And then you divide it by the number of repeating letters. So 1, 2, so you have P is repeating twice, so it's going to be 2 factorial. And you have E that's repeating twice, 2 factorial. And so that's going to give us answer choice E. Number 58, 49x squared plus 81. Now, this is prime, but they're trying to trick you because you've got 2 squares. And the only way you're going to do this, you can look at it as the difference of 2 squares. So let's go ahead and get rid of those. Now, this will give me 49x squared minus 81. Now, if I had minus 81I squared, that would become positive 81 because I squared is -1. So that means my answer choice would have to be K. So we have bivariate data here, and really this is the line of best fit, and here's the equation for that. And let's see, what is the question? What is the absolute value of the largest residual for this model? So the largest residual is really looking for that point that is the farthest away from this line of best fit. And we really need to know, well, what is the difference there? What is the difference when my X value is 32? Well, I know it's 135. And it's almost like you're looking for a margin of error. So we're going to say minus, and we want to make sure this stays positive. So minus, well, what's the Y value that I get over here when I plug in 32? So I'm going to have 1.1 times 32 plus 93. And when you type that in your calculator, you're going to get 128.2. And so if you subtract those two, you're going to get the absolute value of 6.8. So that's going to be answer choice B. And again, the largest residual is really, notice that the point 32, 135 is the furthest point away from our line of best fit. So that's how you determine where to start. All right, for number 60, for the first 5 possible values of X, the certain table below gives the probability P at X that a certain factory machine will make errors on any given day. And then looking at the question itself, it wants to know what is the probability that this machine will make at least 1 error on any given workday. So at least 1, that the only case where that would not happen would be here with no errors. Anything past no errors is at least 1 error. Well, if we add up all of our probabilities, that always equals 1. And so really to find this is just really all of it, the total amount minus the one case that cannot happen here. So going to be the probability of no errors. So 1 minus 0.0823. And when you subtract that, that's going to give you answer choice K.